Hi everyone, this video corresponds with what we did in class on day 1 of chapter 9. So this corresponds again with day 1, notes, classwork, chapter 9. In class today, we talked about crafting a null and an alternative hypothesis, and we talked a little about a p-value and what it means. Today, we're going to do some examples, and we're going to talk about when do we reject the null hypothesis and when do we fail to reject the null hypothesis. So please find this example. It should be right after where we left off today. Calcium is a vital nutrient for healthy bones and teeth. The NIH recommends a calcium intake of 1,300 milligrams for teens. So let's circle that. NIH is concerned that teenagers are not getting enough calcium on average. Oh, let's circle the word average. Is this true? Okay, so you see the word average. Another word for average is mean. So we need to write that down. In our hypotheses, we always only write parameter symbols. Parameter symbols are going to be either mu for means or p for proportions. So because it's a mean question, we're going to use the symbol mu. So you're going to throw a mu here and a mu here. The null hypothesis is always a statement of no change. HO means no change. So you're going to put mu equals 1,300 for this. And in words, that means the average teen is getting the recommended amount, which is 1,300 milligrams. Okay. Now, the alternative is like what we're presuming is true. What we're concerned with in this case is that the teens are not getting enough calcium. That is going to be your alternative hypothesis. And that kind of lends to a less than sign because we're thinking they're getting less than 300 milligrams of calcium. So you want to put a less than sign. This is called a one-sided alternative because you're actually picking a stance on the direction of your HA. And then in words, this would mean that on average, teens are getting less than recommended. Okay, so now we actually want to investigate this by taking a sample. So right now we're going to take a simple random sample, or random sample it says, of 20 teens. That is going to be sample size n equals 20. We think these teens are from our nation, so hopefully they're an SRS of our population of interest. And they find the mean calcium consumption per day of these people and the standard deviation, and then they perform a significance test and they obtain a p-value of 0.1404. Explain what it would mean for the null hypothesis to be true. Okay, so if the null hypothesis is true, that would mean that they are actually indeed getting the recommended amount. If HO is true, then the average teen will be getting the recommended amount of calcium, which is 1,300 milligrams. Okay, so basically what we do in a hypothesis test is we assume that the null hypothesis is true. Just like when you're in the courtroom, you're assumed to be innocent until proven guilty. We're assuming that that null hypothesis is true, and that if we had proceeded with a hypothesis test, we would assume that it would be centered, the sample distribution of the sample mean would be centered at mu sub x bar equals mu, which should be 1,300 milligrams. So I'm creating this picture centered at 1,300, assuming the null is true. Now, when they do the sample of 20, they get their sample mean x bar from that sample to be 1198. And the p-value that they got was 0.1404. So where is that x bar located with respect to 1,300? I'm hoping you're going to say if we had plotted it, it would be to the left of the mean, and it would be a an area that we would have shaded to the left. So the p-value that they located and found when they calculated the test statistic, they ended up getting a p-value of 0.1404, and that is this area under the curve to the left, less than or equal to 1198, okay? So that is what visually we're talking about when we say the p-value. In words, what it means is assuming that the null hypothesis was true, and indeed the average teen is getting the actual recommended amount of calcium, which is 1300, getting a sample, a random sample of 20 teens that has an X bar of 1198 would occur as extreme, meaning 1198, or more extreme, meaning less than 1198, 14% of the time. So you're basically finding the probability of getting your sample value or even more extreme given the null is true. So we have to say this in words. We have to say, assuming that the true mean or the true average amount of calcium in the country for an average teen is 1300 milligrams. The probability, there's your p-value, the probability, which is going to be capital P, if you guys remember from chapter 7. It's capital P, X bar, less than or equal to 1198, basically. That's the notation we did from chapter 7. The probability of obtaining a sample mean of 1198 or less is, and then you put your p-value, which is 0.404. So 0.404 or 14% of the time. Okay, so what does this even mean? It means how likely is it that this sample result occurred by chance? Okay, that's what you want to know is, did your result that you got from your sample of 20, did it happen by chance? Like, oh, just by chance we got a sample of 20 teens that had an average of 1198. Or did it happen for a reason, which is that they are actually getting less than the recommended average. So if the null hypothesis were true, and indeed most teens are getting 1300 milligrams, the actual amount, is it likely that this sample result occurred by chance, or did it occur because actually they're getting less than the recommended amount? So here is when you have to figure out, is your p-value statistically significant or not? Is 0.1404 statistically significant or not? And here is where you have to remember the sentence that I told you, which is, if P is low, reject HO. When P is low, reject HO. How low is the benchmark, we say, is less than 0.05. So we make a decision to reject the null or not based on that, like how low or high that p-value is, and that's considered the strength of the evidence for your HA, which is your alternative hypothesis that you want to prove. If p is low, it's considered unlikely that it occurred by chance. It's really small, okay, less than 0.05. So it's very rare that this happened by chance, so you reject HO. And if you reject HO, you conclude in favor of the alternative hypothesis. But if P is likely to occur by chance, it could have just happened by chance, then the P is greater than 0.05. Then what you do is you say, I fail to reject HO. Okay, so you don't ever really prove HO, you just say, I fail to reject HO. So when P is low, lower than 0.05, reject HO. If P is not low, you can't reject HO. If you cannot reject HO, you say, I failed to reject HO, and then you say there is not enough convincing evidence to prove your prediction, which is your HA. Okay, and then how small? Usually the level that we use is 0.05. This level is called alpha. Alpha is denoted by this lowercase a in Greek. It's called alpha. And the typical alpha level, the most common one we use is alpha equals 0.05. So again, if P is less than alpha equals 0.05, reject the null. That is really the key of what you want to know. When P is low, reject HO. So when we do reject that null, that is called statistically significant, okay? So when we reject the null, we say the p-value is statistically significant at the alpha level, okay? That alpha level here is shown here and there. Again, we say the most common one is 0.05. And basically, it's a benchmark that statisticians use to reject HO. The lower the alpha level, the more evidence actually against the null and in favor of the alternative. So it's kind of like an imaginary line that they draw in the sand that they say if the level is 0.05, then if P is less than that, they reject the null. But if it's even less, like 0.01, for example, when P is less than 0.01, that's actually even more evidence against the null than 0.05 because that's an even smaller P value. So the verbiage that we use is we say if P is less than alpha, then basically the result of our test result is statistically significant at the alpha equals 0.05 level, for example, if we're doing 0.05, 0.01, okay? And the more significant, the lower the p-value. The lower the p-value, the more significant. The lower the p-value, the more statistical significance for your alternative hypothesis prediction. All right, that is everything you need to know in a nutshell here. So I'm going to leave you with this question. I want you to do it. I'm going to read it. I'm going to lead you in the right direction. A company has developed the new AAA batteries. They're supposed to last longer than the regular batteries. However, these batteries are more expensive, so the company would like to be convinced that they really indeed do last longer. Based on years of experience, the company knows that regular batteries last for 30 hours. Circle that. On average. Oh, circle that. The company selects a simple random sample of 15 AAA batteries. So that's their sample. They do a test. They get a sample mean of X bar equals 33.93 from that sample. We're going to do a hypothesis test. Okay, so first thing I want you to do is stop the video right here and craft your hypotheses in symbols and in words. Symbols and words. Go. And then also define your parameter of interest. Go. Okay, so here are my hypotheses. Let's see if you got it right. The null is always an equal sign, so hopefully you put an equal sign. Mu equals 30. The new battery life is the same or no change from the old batteries at 30 hours. And then the alternative is what they're trying to prove. They're trying to prove that the new batteries are going to last longer than 30 hours, so I put a greater than sign. This is called a one-sided tail. So there's a greater than sign. You still use mu and you still use 30. You just flip the sign to be greater than. And then in words, you say the average battery life of the new batteries is longer than the old battery, so longer than 30 hours. And mu is representing the parameter of interest. The parameter of interest is a mean question because it says average. So it's the true mean battery life of the new batteries. Okay, so now they run the test and they get a p-value of 0.0717. So I want you to ask yourself, what conclusion would we make at the alpha equals 0.05 level? So go back to what I just said about is it statistically significant or not at the 0.05 level and see if you can write your conclusion of if you would reject the null or not. Okay, so I'm hoping you realize that P was not lower than 0.05. So you want to say since p-value of 0.0717 is not less than 0.05 because it isn't 0.07 greater than 0.05, you say I fail to reject HO. and you say it is not statistically significant at the 0.05 level. So if you fail to reject HO, you're basically saying I can't conclude in favor of the alternative hypothesis, okay? So go back to your alternative. Your alternative was that the average battery life is longer for the new batteries. So you basically are saying to the company, sorry company, we can't conclude that the new batteries have an average battery life that is longer than the old batteries. Bummer. And we're done. So there you have it. Now you know what a p-value means and what it means in the context of the question.